lesson 7, activity 2. I kind of like this one a little better. You're going into medicine, hopefully, right? This is a regular tetrahedron. Well, this is found in the real world. Carbon, right? I mean, if you're going to do a lot of organic chemistry to get your. I remember I had a buddy. He was in pre-med in college, and you know that organic chemistry about drove him over the edge. It gets crazy in organic chemistry, all the stuff you got to memorize. But a real basis of it is a carbon molecule, right? So if you got a carbon, and you know in a flat representation, a methane is got your 4 hydrogens. But the way they're really configured is as a tetrahedron. And your carbon would be at the center, not at the center of the base or the center of one of these sides, but the very center. And your points A, B, C, and D would be your hydrogen molecule. Now, I don't know if I can do that justice by sketching. It'd probably be a mess. Trying to picture this 3D. You got 2 hydrogens, and then kind of I guess you'd have a third one up there and coming off over here like this. Anyways, it would be your tetrahedron. I don't know. Like I say, very difficult to do it justice. But if you imagine tetrahedron A, B, C, D, and the carbon molecule is in the very center of this pyramid. So that's how it's held together. But anyways, we're going to break this apart. I think this is let me check right here. Oh yes, the last problem is not near as involved. So this is the biggest, baddest one of them all, except for that last problem I did where I messed up the calculation on the last one. Okay, so what we'll have to do once again, you got a 3-dimensional figure, draw it the best you can. Then we're going to break it apart into 2D triangles to figure out all these missing components. So pause the video, do the best you can, spend 10, 15 minutes. Don't get too frustrated, but you know, draw your pictures, do the best you can, then come back here and watch my solution. Okay. So the first thing they're asking us to do is find the height of this tetrahedron. So every side is 15, right? Every edge, not side, edge, I guess you'd say. The edges of the tetrahedron are 15. So let's see. That would be the dead center. How are we going to find that? We want to find this height here. We can see this could make a triangle right here. Okay, over to this corner or this corner, right? You're dividing this triangle up, this base triangle up into 3 triangles, because this has to be in the dead center of mass of it. So let's give this our best shot, and we want to find this height. We've got this. If we could find this length here, boy, wouldn't that be nice? And what is that length there? Let's think about this here. If we can find this length here, well, what is that? I got a 15 here. What would these sides be? These are all, so let's, maybe I'll try to draw that bottom triangle. I'll flip up BCD. Let's flip it up and look at it. We know that each side of this tetrahedron, another great thing about a tetrahedron is each face is an equilateral triangle. All right. So now maybe we can, in this, so we got the center right here, H. I'm calling that H. I think they called it H. Yeah, they made that, right? So let's flip C up, I guess. C up here, B over here, D here. So we're looking up at the bottom of the triangle, I guess you'd say. We're underneath looking up. And we just want to look at this triangle and figure out, because we want to know H to D, correct? Well, each corner, because it's an equilateral triangle, is 60. And so there you go. So this over here would be 30 degrees. And you'd have another one reaching over there. So we can figure out this height because we know this is 15. So how much do you like the... So this is a two-step problem now, I believe, because I need to find this height. So I'll know this, I need to find HD, right? I want to find HD. Then I can go HD squared plus AH squared equals 15 squared. Okay, I can use the Pythagorean theorem. But first, I think I'm going to use the old, our buddy, the cosine rule. I got a 15 here. I'm missing... How about we just drop this? Maybe it'll make it easier. Yeah, let's make it easier. Let's don't use the cosine rule. We could. So let's break it down again. If I do that, then I'm breaking this in half. So I got a 30, 30 and a right angle. I must be left with a 60. Yay, there's our old friend, the 30, 60, 90 triangle. And this, I'm breaking this in half, right? So this equilateral triangle is so cool. So I broke that in half. I got a 7.5 there. So this length would be the 30, 60, 90. So this would be cosine of 30. So cosine of 30 equals 7.5 over what we want. Is that confusing enough? Cosine of 30 degrees equals the adjacent over, and this might not be the way you did it. I'm sure there's another way to do it. So HD, I'm going to get HD equals 7.5 over cosine of 30, which I know cosine of 30 is square root of 3 over 2, right? But let's go ahead and use the calculator here. 7.5 divided by cosine 30, 8.66. I like that number, 8.66. If you break this down into fractions, I think you'll see why, because it's the square root of 3 over 2. And if you did 50, this is 50. Anyways, 8.66 is my HD. So then AH is, I'll go back, if I needed to draw another triangle, I got AHD. Okay? And this is what I want. This is my height. And this is my 8.66. And this is my 15. See, okay. Triangle AHD. So we did that other work to find this length HD. So now we just got this squared plus this squared equals 15 squared. Okay, so H squared plus 8.66 squared equals 15 squared. What is that going to be? I don't even have a good estimate of what that is. But let's just do it. So I'll have the square root of 225, 15 squared, minus 8.66 squared equals 12.25. Let's go 12.25. I like that number, 12.25. Am I off the map here? 12.25. I don't know if it's centimeters or whatever. Let's just go 12.25. Okay. Okay. It wasn't so bad, but it is difficult to see. So every time you got a 3D figure, I suggest breaking it down into two-dimensional triangles, right? Because we're doing trigonometry, which is triangles. Okay, the angle between AB and plane BCD. Where is so this AB and the plane, okay? So anytime it's giving you something like this, well, that's a little confusing, but what that is the angle between this line BH. So we could go ahead and let's rewrite this instead of this being a sentence. The angle between AB and plane BCD. Well, that's more difficult. Now we're going to break it down into being, here's AB, and here's this plane. That's the angle between AB and H. That is angle ABH. So let's just write that instead. So that equals angle ABH. So you're really dissecting things here. You're breaking down more complicated things into chunks you can understand, and it's good, very analytical approach to solving problems, and that's what this math is supposed to be helping you do. Okay, so what do we need to find that angle? Well, oh, we got AH up here, right? So we have AH and we have AB. We don't have any other angles though, do we? Well, we got this is down here as a right angle. So let's draw this triangle again. So we want to draw the triangle ABH. And then we'll figure out that angle. Let's see. So what pieces of information do we have and what are we missing? So I got angle A, I got triangle ABH. And we know AH is 12.25. We know this is 15. We know this is a right angle. And we want this angle. Hey, that's not so bad. I have an angle I know and the side opposite of it. And I have an angle I don't know, but I have the side opposite of it. So what am I going to use? I apologize for my colloquial American English. I don't need to say what am I going to do. What will I do? What should we do? Let's go with the sine of H divided by, and we'll call this little h, right? And this is little b. So I got the sine of h over h equals the sine of b over b. So the sine, what is the sine of 90 degrees? We know that one, don't we? Over 15. I guess I should flip them over. I could have, and then I'd have 15 over 1 equals sine of b over 12.25. So I'm going to multiply that over here. So I'm going to have 12.25 divided by, because sine of 90 is 1, correct? Yep, that's what I remember. And you've got that whole chart you've got in your head. So then I'm going to multiply this side. I'm going to take sine inverse. So I'm going to have sine inverse of, so angle B, which is angle ABH, angle ABH equals sine inverse of 12.25 divided by 15. All right, I wonder what that angle is. I wonder what it is. It's definitely less than 90, you know, so what would it be? Could we get any closer in our estimation before we hit the buttons? I don't know. Let's just do it. Sine inverse of 12.25 divided by 15 and it equals 54.75. I don't know how, one decimal place. So this angle equals 54.8 degrees. Okay. Oh yeah, that was supposed to be 12.3, right? 12.3. One decimal place. Anywho. Last part. How long is this video? Good grief. Sorry about these long videos, but these are long problems, and where I'm working through them and drawing all the stuff. So, okay, the angle between any two faces. Now, this, I got to draw another picture. I would love to be able to use what we've found already, and this is a whole nother ball of wax. So. There's no the angle between two faces would be like, here's this face over here. Let's see if I can draw this again. I don't know. And maybe you already figured this out, and maybe I'm wasting my breath. I don't know. Let's see if this is a decent drawing or not. And this over here and this over here, right? I shouldn't have drawn that in so darkly. But anyways, let's see. I've got this face here, and this face here. What I want the angle, man, that's difficult to see. Well, maybe I should do the bottom one. But anyways, this angle between this, if I drop down to the center here and I went over to this here, that's what it's talking about. This angle between, say, the bottom. I should have two different colors here. Let's see here if I can do it one more time. Try it again. Try it again, Sam. Try it again. All right, so I've got this face, and I got my bottom here. Let's try that one. So I want to do the angle, this up to here. And I don't know if you can see that or not. It's going to be this angle. So I'm going to have to make another point. So make point here, A, B, C, D, E maybe. Point E. Okay, so I'm going to have, I need to find, I can see, can you see what you want to find now? I want to find this here. I've got point E. I want to find, I've got this 15 here, so I can see that opposite side, and I want this angle that's opposite that 15, right? And so I need to find this length and this length. So the height of one of these faces, well, that's not too bad, since this is a, let's look at one of these faces again. They're all the same, but just for our sake, we'll look like we're looking at ABC. Right? And we got point E right here. E, and this is A, B, C. I want to find this length right here, this height of this triangle. So I got 15. This is 15. This must be 7.5. Oh, it's our old friend, right? Because this has got to be 90 because I dropped it down to the center point, right? 7.5. That'd be 90 degrees there. So this is 60. This is 30. So what is this height here? We got the either the sine of 60 or the let's see. The cosine of 60 or the sine of 30. What is a sine of 30? No, and I want to find this. I'm sorry. We don't need any of that. Ugh. Pardon me. I guess I need to take a break, drink some more tea. So we got two sides of a right triangle, and we need to find a third side. So let's just go 7.5 plus squared plus AE squared equals 15 squared. AE equals the square root of 225 minus 7.5 squared. Don't forget that this time. That's me. Reminder to me. Okay, square root. Oops. Oh, here we are. Sorry. All right. Square root of 225 minus 7.5 squared equals 13. So that's not our answer. Sorry. So that's AE. That's the length of AE. So that is what we want, though. We got AE, and this bottom would be the same thing, right? This is the height of one of the faces is 13, approximately. So the height of one of the faces. So then I want to just know I've got this triangle with a 13, a 13, and a 15 opposite. So let's use our friend, right? To find that angle. So I got 15 squared equals 13 squared minus 13 squared. Plus, minus 2 times 13 squared, right? 13 times 13, right? Cosine of our angle. The angle. Let's call it angle E. So angle, we're going to call it angle AED or something, the angle between the faces. Angle AED equals 15 squared minus cosine inverse of 15 squared minus 13 squared over minus 2 times 13 squared. Okay, this looks like what I messed up on last time, so I'll try not to forget to square my terms. And we hopefully we come out with a, I wonder what it'll be, somewhere around. What is that other angle we found? Didn't we find another angle? 57 degrees. What was that angle? Angle ABH. That angle. It shouldn't be a whole lot different. Maybe it's a little less than 54, or is it greater than 54? I don't know. Somewhere around there. 50 something, 60 degrees, something like that. Okay, let's try it here. Let's try to put it all in here. And I hope you're getting real good at putting in all this information. The better you get at this, the better you can do on that test. So cosine inverse 15. I better do another. Clear. Shift cosine inverse. Another one. Bracket 15 squared minus 13 squared minus 13 squared in brackets, divided by a negative 2 times 13 squared in brackets equals. Oh, bummer. What went wrong? Okay, let's clear it again. Try again. Shift cosine inverse of, let's put a bracket on it. Bracket 15 squared minus 13 squared minus 13 squared. In that bracket, divide by a negative 2 times, and that's going to be okay, right? I'm going to do 13 squared in bracket. Oh, well, I hope you can figure out where I'm making my mistake. But I'm satisfied with all my drawings and what I've done here, and I can't believe this is 23 minutes. This is the worst problem ever. I mean, I like it because it's a tetrahedron. Like I say, it has applicability in the real world. And I don't know where I've gone wrong in my calculations, but maybe you can track that down. If you can't track it down, well, I'll rework this one with you or something. Okay, tell me if you want me to rework that one. It's probably just how I'm putting in that calculator. Okay, good luck on this one. Sorry I messed up on the calculation at the end.